Welcome to Barishal Cadet College and good morning to you all. Hope you all are fine at your home. Dear cadets, you have to follow the preventive tips for your safety. Firstly, wash hands with water and soap or sanitizer at least 20 seconds. Avoid contact with sick people. Don't touch eyes, nose or mouth with unwashed hands. Don't eat raw food, thoroughly cook meat and eggs. Avoid contact with animals and animal products. Due to corona pandemic, our regular classes are not taking place. So now I am here to take your class virtually. I am Abu Said, lecturer, Department of Mathematics, Barishal Cadet College. In this class, I am going to discuss probability from chapter 10b of your book, Learning Outcome. After the class, you will be able to solve simple real-life problems involving probability. Now, first question. A uniform coin is tossed thrice. Write down the sample space and find the following probabilities. Question number A. If in every toss, probability of having head, in every toss, probability of having two or more heads, probability of having at least one tail, probability of having heads and tails successively. You tossed a coin thrice, then find the probability of this. Now solution. If a coin tossed thrice, then the sample space is head tail into head tail into head tail. That means head 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 tail tail head tail tail. Again, if we cross multi-product here, then we can write head 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 tail head tail head head tail tail. In the same way, we get this term. Here the total number of sample point 1, 2, 3, 4, 5, 6, 7, 8. That means NS is equal to 8. So probability of getting hit in each toss 1/8. Set of sample points having two or more hits on the condition of the having heads first is here first head 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 tail head tail head. That means 1, 2, 3. Probability of having two or more heads on the three condition. Here 1, 2, 3. Three condition of having heads first is, that means we know from the definition of probability, favorable number of favorable outcomes by total number of outcome divided by total number of outcome. That's why we can write 3/8. Now question number C. Set of having two or more heads without any condition. That means head, 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 here two heads, here two heads, two heads, and also here is two heads. That's why the number of sample point 1, 2, 3, 4, 4. Probability of having two or more heads without any condition is 4/8. That means half. 4/8. That means half. Set of having at least one tail is at least one tail. That means one tail, one tail, 1, 1. That means 1, 2, 3, 4, 5, 6, 7. The number of sample points 7. So probability of having at least one tail is 7 by 8 because the total number of outcomes 8. Now question number E, set of having heads and tails successively. That means head, tail, head. The number of sample point 1. That's why we can write the probability of having heads and tails successively 1 by 8. Now another question. A box contained 5 red and 4 white balls, and other box contained 3 red and 6 white balls. One ball is drawn from each box. Find the probability that two balls may be same color, different color, or at least one red. That means they are given that two box, and first box contain 5 red and 4 white. Also second box contain 3 red and 6 white. Now one ball is drawn from each box. Then find the probability of two balls may be same color, different color, at least one red. Now solution. First box, total number of balls 5 plus 4, that means 9 balls. And second box 3 red, 4, 6 white, that means 9 balls. If one ball is drawn from each of two boxes, then the probability there's 3 balls that these balls be of same color. That means first box red and second box red, or first box white or second box white. They are same color, that's why first box red, also second box red, and first box white, second box white. Now we know the first box red. The first box red ball is here 5. The total number of ball 9. That's why we can write the first ball box red. The probability of red ball is 5 by 9. That's why we can write 5 by 9. And here two events are independent. That's why the two events are independent. That's why here we use multiplication, the symbol of multiplication. And second box is red. Here second box 3 red balls. That's why we can write the probability of 3 by 9 because the total number of balls is here 9 and the red balls 3. That's why we can write 3 by 9. In the same way, we can write in the first box white. Here first box 4 balls here are white and total number of ball 9. That's why we can write 4 by 9. Also the two events are independent. That's why we can write into 6 by 9. Now after calculating this, we can write 13 by 27. This is our required answer for same color. Now different color. That means two balls are different. If first ball is red, then second ball white. Or if first ball white, then second ball is red. Now different colors. That means first box red, second box white. Here first white, so second red. Here also the two events are independent. That's why here we use multiplication sign. First box red. Here 5 red balls. That's why we can write the probability 5 by 9. And 6 white ball. That's why we can write 6 by 9. Here 4 white ball. That's why 4 by 9. And 3 red ball. That's why 3 by 9, the probability. After calculating this, we can write 14 by 27. Now at least one black. That means 1 minus red from both box. first 1 minus first box rate and second box rate. That's why we can write 1 minus 4 by 9 into 6 by 9. That means 19 by 27. Now another question. A bag contains 5 red, 3 black balls. Another bag contains 4 red and 5 black balls. One bag is selected by a lottery and 2 balls are drawn from that bag. Find the probability that one ball may be red or other be black. Here a bag contains 5 red balls, 3 black balls, and another bag 4 red, 5 blacks. One bag is selected random. Here two bag. Firstly, we selected one bag. So the probability of one bag is 1 by 2. And that bag's 2 balls are drawn from that bag. And find the probability that one ball may be red and other be black. Now solution. First bag contains 5 red, 3 black. That and total 8 balls. And second bag contains 4 red and 5 black. That means 9 balls. If one bag is selected by lottery, then the probability of any bag be selected 1 by 2 because here 2 bags. After selecting one bag, if 2 balls are drawn, then the probability of being one red and one black. Here firstly we select a bag, that's why we can write half. Then from first bag, first red and second black, or first black and second red, or from second bag, first red and second black, or first black and second red. That's why we can write half into 5 by 8 into 3 by 7 because two events are independent. Also, two are mutually exclusive event. That's why here you use plus into 3 by 8 into 5 by 7 plus 4 by 9 into 5 by 8 plus 5 by 9 into 4 by 8. After calculating this, we can write half into 30 by 56 plus 40 by 72. That means 275 by 504. Here 5 by 8. That means favorable number of outcomes by total number of outcomes. Here total balls 8, and given that the 5 red balls and 3 black balls. First bag, also the second bag 4 red and 5 blacks. That's why we can write 5 by 8, 5 blacks and 3 red. There's a 3 by 7. In the same way, we can write these terms. This is our required answer. Now another question. A bag contains 1 taka coin and three 1 paisa coins. Second bag contains 2 1 taka coin and 4 1 paisa coins. And third bag contains 3 1 taka coins and 1 paisa coins. If one bag is selected by lottery and a coin is drawn at random from it, and the probability of its being 1 taka coin. Here 3 bags. Firstly, we select one bag is random. Then a coin is drawn at random from it. Then the probability of being is 1 taka coin. Now solution. First bag contains 1 taka coin and 3 1 paisa coins. And second bag contains 2 1 taka coin and 4 1 paisa coins. Third bag contains 3 1 taka coin and 1 1 paisa coins. if one bag is selected randomly. Here 3 bags, that's why we can write the probability of one bag 1 by 3. After selecting one bag, if one coin is drawn from the probability, one coin is drawn, then the probability of its being taka is being 1 taka. That means we can write firstly we select bag, that's why we can write 1 by 3. Then taka from first bag or taka from second bag or taka from third bag. That's why we can write 1 by 3 into here 1 taka and total number of coins 3 plus 1, that means 4. That's why we can write 1 by 4. Also second bag had 2 1 taka and 4 1 paisa coins, that means total number of coins 6 and 2 taka 1 taka. That's why we can write the probability of 1 taka 2 by 6. And also third bag here 3 1 taka coin and 1 1 paisa, that means total number of coins 4 and 3 1 taka coin 3, that means the probability of 1 taka 3 by 4. After calculating this, we can write 4 by 9. This is our required answer. Now another question. In an examination, 30% of students failed in mathematics, 20% of the students failed in chemistry, and 10% of the students failed in the subject, in both subjects. A student is selected random. Then what is the probability that Lai failed in mathematics when it is known that he failed in chemistry? That means this is conditional probability. Here we know first he failed in chemistry. Now we find also he failed in mathematics. Question number B. What is the probability of the student of failing in only one subject? Now solution. Let the probability of failing in math is 30%. That means P of M is equal to 30 by 100. And the probability of failing in chemistry is 20%. That means 20 by 100. P of C, Siemens chemistry, 20 by 100. And failed in both subject, 10%. That's why M here mathematics, C is chemistry. That's why M intersection C. Probability of failing both math and chemistry. That means P of M intersection C is 10 by 100. You have 10%. That's why you can 10 by 100. Now we can find what is the probability of being failed in mathematics when it is known that failed in chemistry. Here we know he failed in chemistry. This is a conditional probability. Now we find also failed in mathematics. That's why we find P of a student selected random. The probability of that he failed in mathematics when it is known that he failed in chemistry is P of M condition C. Here known event is chemistry. That's why here C is the denominator. We know the definition of conditional probability. P of M intersection C. Here the known event is the denominator and also the common event the numerator. That's why we can write from the definition of conditional probability, P of M by C is equal to P of M intersection C by divided P of C. Here given that P of M intersection C is 10 by 100 and P of C 20 by 100. After calculating this, we can write 1 by 2. Now question number B. The probability of the student of only one subject is, that means either mathematics or chemistry. That's we know the formula from not mutually exclusive event. P of M intersection M union C is equal to P of M plus P of C minus P of M intersection C. Now putting this value here, we know P of M is equal to 30 by 100, P of C is equal to 20 by 100, and the common event is 10 by 100. Here 2 by 5, this is our required answer. Now another question. A candidate applied for the 3 posts in an industry. Number of candidates for first, second, and third post are 3, 4, and 2 respectively. What is the probability of his getting at least one job? A candidate applied for 3 posts in an industry. Number of candidates of first, second, and third post are 3, 4, 2. So what is the probability of his getting at least one job? Now solution. Let the event of getting job in first, second, and third post A, B, and C. Here 3 posts. Now let the events of first, second, and third A, B, and C. So we can write P of A 1 by 3 and P of B 1 by 4, P of C 1 by 2, because the total number of event 3, 4, and 2. And probability of not getting job in the first post. Here probability of getting job is 1 by 3. So not getting of job 1 minus 1 by 3. That's why we can write P of A complement is equal to 1 minus 1 by 3. That means 2 by 3. In the same way, we can write P of B complement. That means not getting a job in second post is 1 minus 1 by 4. Here 1 minus 4. P of B complement is equal to 3 by 4. In the same way, we can write P of C complement is equal to 1 minus half. That means half. Now, the probability of not getting of the 3 jobs. Probability of not getting of 3 jobs. That means P of A complement intersection B complement intersection C complement. Here 3 events are independent. That's why we can use multiplication sign. That means P of A complement into P of B complement into P of C complement. Here A complement means 2 by 3, B complement means 3 by 4, and C complement means half. Now putting this value here, then we can write 2 by 3 into 3 by 4 into half. That means 1 by 4. A box contains 6 red, 5 green, and 4 white balls. 3 balls are drawn at random. Find the probability that 3 balls may be of different color, same color, 2 red balls, 3 green balls. Here, a box contains 6 red, 5 green, and 4 white balls. 3 balls are drawn at random. Find the probability of these balls may be different color, same color, 2 red balls, 3 green balls. Now solution. Here total number of balls 15. If 3 balls are drawn at random, then the probability that this ball may be different color. First here may be different color. That means either red or green or white. That's why we can write 1 red, 1 green, and 1 white. That means we can write the total number of event, total ball 50. Now we're getting 3 balls. That means total number of balls 50C3, 15C3, and 1 red. That means 6 to 1. That means 6C1 into 1 green. That means 5C1 and 1 white. That means 4C1. After calculating this, we can write 24 by 91. Now for same color, that means 3 red, 3 green, and 3 white balls can be selected. 6C3 plus 5C3 plus 5C3. That means 34 ways. and the total number of balls 15C3, that means 455 balls. Now the probability of that 3 balls may be of same color, that means 34 by 455. Now question number C, 2 red balls means from 6 red balls 2 and from other 5 plus 4, that means 9 balls 1 will be selected. The probability 2 balls will be red and 1 different color, that means 6C2 into 9C1 by 15C3. After calculating this, we can write 27 by 91. Now probability that 3 balls will be give green. 3 balls green, that means 5C3 by 15C3. A total number of even 15C3, that means 2 by 91. This is our required answer. Now this is your homework. A box contains 10 red and 4 black balls of small size. The other similar box contains 12 red balls of same size. A box is selected by lottery and a ball is drawn from that box. If the ball is red, then what is the probability of that being selected from first box? Now question number B. If a coin is tossed thrice time, find the probability that head and tail may be occurred alternatively. Now question number C. Find the probability there are 53 Friday in a leap year. That's all for today. If you have any query, you can ask that in the comment section. Lastly, I would like to remind you the most important things. In this critical situation, you must stay home and keep yourself safe. Stay fine. Thank you.